Hello, my name is SHAWN GALLEW, and I will be discussing denial of service attacks. During this discussion, I'll be going over the symptoms of denial of service attacks, different attack methods, different types of denial of service attacks, and ways that you could prevent and or mitigate denial of service attacks. The United States Computer Emergency Readiness Team defines symptoms of denial of service attacks to include unusually slow network performance when opening files or accessing websites, the unavailability of a particular website or the inability to access any website. There may also be a dramatic increase in the number of spam emails received, and you may experience a disconnection of a wireless or wired internet connection. There's also denial of service attacks can also lead to problems in the network branches around the actual computer being attacked. For example, the bandwidth of a router between the internet and a LAN may be consumed by an attack, compromising not only the intended computer but also the entire network. A denial of service attack can be perpetrated in a number of ways. The 5 basic types of attacks are the consumption of resources such as bandwidth, disk space, or processor time, the disruption of configuration of information such as routing, the disruption of state information such as the resetting of TCP sessions, the disruption of physical network components, and also obstructing the communication media between the intended users. Now, they may also include execution of malware, which would be intended to max out the processor's usage, such as preventing any work from occurring, also triggering errors, forcing the computer to an unstable state or a lockup. There are multiple types of denial of service attack. The ones we're going to be discussing today are the ICMP flood, such as Smurf attacks, ping floods or ping of death, also SYN flood, teardrop, an older version called nuke, Rudy, and slow read, and also also I'll be discussing distributed denial of service attacks very briefly. It is another topic, but we're going to go over that briefly here today. The first type of attack we're going to be discussing is a Smurf attack. This attack is on the public internet, and it relies on misconfigured network devices that allow packets to be sent to all computer hosts on a particular network via the broadcast address of the network rather than a specific machine. This attack is not very common, and that is because most routers are able to be configured in a way that prevents them from forwarding the broadcast packets to other networks. The next attack is the ping flood attack, and this is based on sending the victim an overwhelming number of ping packets, usually using the ping command from Unix-like hosts. It is very simple to launch, the primary requirement being access to greater bandwidth in the victim. The ping of death attack is based on sending the victim a malformed ping packet which might lead to a system crash. A SYN flood attack occurs when hosts send a flood of TCP SYN packets, often with forged sender addresses. Each of these packets are handled like a connection request, causing the server to spawn a half-open connection by sending back a TCP SYN ACK pack and waiting for a packet in response from the sender address. However, because the sender address is forged, the response never comes, and thus flooding the network. The teardrop attack involves sending mangled IP fragments with overlapping and oversized payloads to the target machine. This can crash various operating systems such as Windows 3.1, Windows 95, as well as Windows NT and also older versions of Linux. Notice that these are on attacks of older machines, and this type of attack normally does not happen today because of the prevention techniques we have in place. A nuke is, like I just said earlier in this discussion, is an old denial of service attack against computer networks consisting of fragmented or invalid ICMP packets sent to the target. And this is achieved by using a modified ping utility to repeatedly send this corrupt data, slowing down the affected computer until it comes to a complete stop. A specific example of a nuke attack that gained some prominence is called WinNuke, and this occurred on the Windows 95 server, and it exploited the vulnerability in the NetBIOS. The next attack we're going to be discussing is known as Rudy, also known as Are You Dead Yet? This directly attacks web applications by starving of available sessions on the web server. Rudy keeps sessions at a halt using never-ending post transmissions and sending in arbitrarily large content length header value. The slow read attack sends legitimate application layer requests but reads responses very slowly, and this is achieved by advertising very small number for the TCP receive window size. And because it is processing the attack very slowly, it naturally ensures a very low data flow rate. A distributed denial of service attack occurs when multiple systems flood the bandwidth or resources of a targeted system. This is a result of multiple compromised systems, known as botnets, which are flooding the targeted system with traffic. A well-known or classic example of a distributed denial of service tool is known as Doppeldraht. It utilizes a layered structure where the attacker uses a client program to connect handlers, which are compromised systems that issue commands to the zombie agents, which in turn facilitate the distributed denial of service attack. The major advantages to an attacker of using a distributed denial of service attack are that multiple machines can generate more traffic than one machine. Multiple attack machines are harder to turn off than one attack machine, and that the behavior of each attack machine can be stealthier, making it harder to track down and or shut down. Defending against denial of service attacks typically involves the use of a combination of attack detection, traffic classification and response tools, aiming to block traffic that they identify as illegitimate and allow traffic that they identify as legitimate. The first tool or method you can use is your firewall, which can be set up to have simple rules such as to allow or deny protocols, ports, or IP addresses. Switches have a rate limiting and ACL capability to detect and remediate denial of service attacks. Similar to switches, routers have some rate limiting and ACL capability as well, and they also have features that prevent flooding. Application front-end hardware. This is intelligent hardware placed on the network before traffic reaches the servers. It can be used on networks in conjunction with routers and switches. The application front-end hardware analyzes data packets as they enter the system and then identify them as priority, regular, or dangerous. Intrusion prevention systems, also known as IPS systems, are effective if the attacks have signatures associated with them. Intrusion prevention systems which work on content recognition cannot block behavioral-based denial of service attacks. Black holing. With black holing, all the traffic to the attack DNS or IP address is sent to a black hole per se. or also known as like a null interface or a non-existent server, to be more specific. Clean pipes during clean pipes, all traffic is passed through a cleaning center or a scrubbing center via various methods such as proxies, tunnels, or even direct circuits, which separates bad traffic and only sends good traffic beyond to the server. Okay, that is our discussion for today. We went over symptoms of denial of service attacks, different attack methods, and we went over a few types of denial of service attacks. Of course, that's not all of them, but we did discuss the most known today, and also some that were prevalent in the past. And we also went over some prevention techniques that you can use to prevent denial of service attacks from happening on your server or system. If you do have any questions, my contact information is listed here. You can reach me at shawn.gallew@gmail.com, or of course you can use the AACC email, which I don't use all the time, however. But thank you for your time. I learned a lot during this. Again, my name is Shawn Gallew, and please do send me questions and/or comments or feedback, and I'll appreciate everything. Thank you very much.